Okay guys, you should probably start feeling pretty good because we're about to finish, or we're really close to finishing our Chapter 10 practice test. Looking at question 13, I'm seeing an f of t, which looks a lot like a geometric sum, and a g of t, which is an antiderivative of that geometric sum. So for part A, we were just being asked to find the first four terms and the general term for the Maclaurin series generated by f. So let's remember that for a geometric series, any geometric series, including this one, a over 1 minus r is equal to a plus ar plus ar squared plus ar cubed plus a multiplied by r to the n power. And of course, n is equal to 0, 1, 2, 3. Basically, just stating that n is starting at 0 and not starting at 1. And if we apply that to what we see from their geometric sum, 2 over 1 minus t squared, you'll get this nice result, which someone really nice wrote for you. The first term is 2 and the ratio is t squared. So we're just going to fill in. Anytime I see an a, I'm going to put a 2. Anytime I see an r, I'm going to put a t squared. So here's my first r. We'll put a t squared here. This is t squared squared, so t to the 4th. This is t squared cubed, which is t to the 6th. And this is t squared to the n, so t to the 2n. And look at that. That is my first four terms and my general term, all wrapped up in one. I kind of wish I made this a little more, I don't know, parallel to the bottom of the paper. This isn't paper, this is a screen. That's just me being silly talking now. Alright, next part, we're going to find the first four terms and the general term for the Maclaurin series for g. Well, what is g? G is the integral of f from 0 to x. So for b, we're just going to take the integral of what we had in part A, and we're going to integrate that from 0 to x. Okay, and it's a term-by-term integration, which is just a fancy way of saying you're just going to integrate each term. So 0 to x, oh, I should probably say this is g of x. G of x equals the integral of 2 plus 2t squared plus 2t4 plus 2t6 plus, I don't know why I wrote 2t to the 8th, totally unnecessary, 2t to the 2n plus dot dot dot, and then dt. Great. Antiderivative of 2 is 2t. Antiderivative of 2t squared, 2/3 t cubed. Right on down the line, 2/5 t to the 5, 2/7 t to the 7th. 2 is constant, so I'm just going to write it. And then, well, maybe I should have saved a little bit of space down there. Got really excited to write that 2. 2 is on the numerator. 2n plus 1, t to the 2n plus 1. Don't forget we have endpoints from 0 to x. Substitute that x, and all those t's just turn into an x. And what happens when I substitute 0? Well, I get 0. So I don't know if it's necessary for you to write that minus 0 at the end there, but you definitely should be thinking about that minus 0 at the end there. It may not be a 0, but it is there. So there's our letter B. And finally, letter C. This is the one where a lot of people are weirded out by. We're going to write the first four terms in the general term for f of t minus 2 minus 2t squared, everything over 2t squared. And the main thing to remember with this one for h is you only need to substitute that series for f of t just that one time. Okay? So h of t, I mean, I see all sorts of weird things, or I have seen all sorts of weird things here, where people substitute that f of t multiple times, and I can't really explain why people do that. Okay, so I'm going to go ahead and write f of t as a series 2 plus 2t squared plus 2t to the 4th plus 2t to the 6th, 2t to the 8th. It does say general term, so I'm contractually obliged to write that 2t to the 2n plus dot dot dot. So there's my f of t. I see my fraction bar is not long enough. Now I'm going to minus 2 and I'm going to minus a 2t squared and shove that whole thing over a 2t squared. There we go. That is a long expression. Let's just look at it and admire it for a second. Okay, that's enough time. Do things cancel out? Well, yeah, they do. This 2 here is going to cancel out with that minus 2. This plus 2t squared is going to cancel out with that minus 2t squared. And yeah, I'm left with this decidedly smaller polynomial. 2t to the 4th, 2t to the 6th, 2t to the 8th. Ooh, that's only 3 terms. I'm going to need the next one. 2t to the 10th, 2t to the 2n, and that's the only thing that's left on my numerator. Last thing I need to do is divide. So when I divide the 2, well, basically all those 2's are going to cancel out. And then when I divide by 2, you're going to subtract 2 powers from every one of those t's. So decrease all those powers by 2, and you've got it. T squared plus T4 plus T6 plus T8 plus dot 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 plus T to the 2n minus 2. Again, we're decreasing by 2 powers. And that looks good. I think there's a letter D here, so let's get to that. What h of t is approximated by this series? Well, what series is this? What kind of series is this? Whenever it's asking you for the function that goes with a series, there are really only two broad categories to look at. Number one, it could be a geometric series. Number two, it could be a Maclaurin series that you've hopefully memorized by now. This one here looks geometric. First term, should write the word geometric. First term is a t squared, and that repeated ratio is also t squared. Ooh, that's nice. So the sum of the series h of t is a geometric sum, which is a over 1 minus r, which is t squared over 1 minus t squared. And we're done. Okay. Good luck on your test. Or, no, I guess you'd be going to number 14 after this.